Hello everyone and welcome back to the channel. This is the Tiny Swift from Tomo Quads. It's 59 millimeters. FlexRC FX1103 10,000 kV motors. Emax Femto flight controller. I mounted the board wrong. Racerstar 6 amp 4-in-1 ESC. CM275T with a whip antenna. Cut down Hubsand props. It weighs 43.8 grams. Motor to motor, it's smaller than the Tiny Whoop. I've been flying with my LiPo and over SkyRC batteries. Flight time on these batteries is about 2.5 minutes. These are my PIDs, and this thing is tough. Full parts list in the description down below. We have a new leader in the smallest brushless micro, and it's from Tomo, of Tomo Quads fame. The Tiny Swift here, as you've seen in flight, this one is a lot of fun. I have enjoyed it quite a bit, and I think the one thing that Tomo did that we haven't seen before is TPU printed struts. Oftentimes the struts are what get damaged, and then you end up where you don't have a cage on, but he's using TPU out here, which flexes and gives us a little bumper, and it grabs the screws real nice. And then we have additional TPU printed parts here, and this center pod that is actually printed in the harder print material, as well as the camera mount. You do get two camera mounts. This camera mount is designed to use with a what they call a mullet, which I went ahead and painted one up, but I decided not to use it because it does raise the profile ever so slightly. And if you've seen my videos before, you know I like a low profile. As I mentioned in the intro, for whatever reason, it never occurred to me to rotate the board clockwise. I rotated it counterclockwise. I put myself in a bad spot with that USB port, so I couldn't do my PID tuning without taking a motor off. But you know, I've had that situation before, got kind of used to it. So when you build yours, make sure you do it as designed by mounting it to where the USB is out the back. You do cut this down, and you can cut this down more. I just left it where it was. One of the things that I did differently on this one, and I can't say that it was any sort of pre-planned, it was just kind of what I had on hand, is the foam I used down here to mount my battery to get it above the screw knobs here is relatively soft, and I think that might help keep some vibration down. If you get any battery waggle, that the extra cushiony double-sided tape here might help us decrease some of that vibration a bit. Tomo also includes a prop cutter like this, where you put your fingernail clippers in there and you secure them down, and then you put your prop with some sort of needle or anything you can find that fits the props in there. You make your adjustment, you clip it. But he also has this one, which doesn't require anything, and it's made perfectly. It's 40mm prop cutter. And so you put your quad blade props in there and you secure it, and you take your clippers around the edge, and it works quite well. I've actually got a set here of Racerstars that I cut down, but you notice it's not on the quad. Now, something that I'm finding with these, especially as we get smaller, as we start to cut these props down and we have a little bit of more mass, that I like these Hubsand Triblades better. So I've been tending to fly with these Hubsand Triblades. Now, these were fairly well tested back when they launched in the brushed micro scene, and they were kind of panned as inefficient and didn't actually increase thrust very much. And maybe it's because they just needed higher RPMs, which we can get out of these motors. Speaking of props, even though we have prop guards, I've broken a few props. Not to worry, that's why we all have spares. I'd rather break props than break the vehicle, right? I really think it's cool that Tomo included a prop cutter for us. That's extraordinarily handy, and I think a great value and a great idea for a designer to go ahead and include something like this, because that was initially something I struggled with. I had a hard time cutting down props, and what I did was I started scouring the internet. I spent too much money, and I bought several things like this and other pieces where you had to go out to the hardware store and you had to find little bits and bobs to make it work. And most of the time that I have available to me is either over lunch hour or it's this time of night where it's dark out and all the shops are closed. But if you don't want to use this prop cutter, I highly suggest getting one of these from Winder Wonder Works. I bought this when I got the swirly, and I thought the design was really cool. I have no idea what those are for over here. Maybe you can tell me why those little bits are cut out. But it's already got the hardware and the fingernails, everything, fingernail clippers, everything comes right with it. It's got this brass fitting here. You just turn this, flip it over, put your toothpick through the hole, put your prop down on it. These, of course, have already been cut. And you just clip, 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 whoop, clip it out. So this works great if you want to try tri-blades or you want to increase your flight time. You can try just 2 leaf props and use one of these to cut it down if you want. And I'll link everything down below. Not just the prop cutters, but all the parts that it took to assemble this. Probably the most ingenious part out of the design of this frame, other than the TPU printed parts, is how he managed to make this smaller. And we can see that he's got this, it's kind of a T or star shaped pod here in the middle to get the camera up out of the way of the props, and also gives us some clearance. That also makes me think we're not going to be able to go much smaller, because the closer these props get to each other, the more thrust we're going to lose. We might end up flying a little bit of wobble-dee or something, because I just don't know how much it can compensate for too much thrust going down in here. But at this size, it works great. And as you've already seen, it flies really well. And quite honestly, this one took very little tuning. We'll walk through the entire Betaflight, and you can take a look at all the setup. I found that I only took it out to just slightly change some of the P values, and other than that, I've been very happy with it. Of course, I changed my rates. I really don't have much more to say about the vehicle. The flight video, I think, tells it all, and we'll have some more flights coming up here in just a moment. We'll walk through Betaflight, as I said. It's a great design, and I encourage you, if you have any desire to have an indoor flyer, you should get one. And they're so much fun, and if you're like me, that the weather has stunk. I've actually got a 5-inch quad over here I'm supposed to be taking a look at, but I haven't had a chance to fly outside in probably 12 days. It started raining before I got the frame. And speaking of the 12 days, it's probably been since I last posted. I've been busy at work, and that's a good thing. Being busy at work makes the days fly by, and that has really taken up most of my time. I did go ahead and I built this one here and there. I didn't really sit down on one night and build it, so I took my time and I did film it. And you probably notice in the build video it might be a little bit chopped up because I just kind of did one thing here and then I'd go on with the rest of the night or go to bed. I've already got one more. Not one of these, but something very similar to this that'll be coming to the channel soon. I've already got that one built and I have been flying it. Speaking of flying, here's a look at what it looks like in my directory of all the flight footage. And I've got about 25 or so flights in there that I've recorded. There's been lots of flights that have been ugly or short, or one of the kids did something or something of that nature that I went ahead and just threw that out because it didn't have any footage I felt would be usable. And that brings me to a point. How important is it to you, or what value does it add to you having a full flight? Most of the time when I visit a channel, and I visit all sorts of quadcopter YouTube channels myself, I find a lot of short bursts. And oftentimes I find for myself that doesn't really tell me if I'm interested in the vehicle or not. And that's one of the reasons why when I started making YouTube videos, I was posting full flight footages. Yeah, I do have the little teaser that I'll do anywhere from 20 seconds to 60 seconds or what have you. But I usually always post at least one full flight, if not two, for every vehicle that I review. And how important is that to you? So before we get to the full flight footage that you're going to see, think about that for a second, and please post in the comments down below. Even if you're indifferent. If you're indifferent, just put, it really doesn't make any difference to me. I just want to see the thing fly. If you feel it adds a lot of value, put that. If you don't care, put that. I'm just looking for some feedback here, because sometimes my best flights don't actually make it into the video because I'm not recording the audio. I put a camera phone on a tripod on the table when I'm flying inside, and that picks up the audio, and that has confused a few people thinking that I have audio on the little vehicles. I don't. It's all from a stationary camera, but sometimes I forget to record. And then when I don't have record, I know that there's a good few of you that like that, so then that flight goes out the door. So that means, I hope I can reproduce that fun flight I just had. So let me know. I'll probably continue to include a lot of audio and full flights because that's what I enjoy, and I try to make videos I enjoy, but I am curious about what you guys think. All right, enough of me droning on. Let's get to the flight footage, and then we'll take a look at the build video, and we'll cut to one more flight after that. Unfortunately, I don't have any outdoor flight because, again, the weather has been stinky. We have all our kit contents laid out here, and I want to draw your attention to a few things here. Of course, this is going to use a 4-in-1 ESC, and we just covered that in the last video. And of course, we've got our femtoe here from Emax, and our foam pad. You get 2 of these with your femtoes, so you'll have spares in case it doesn't stick down right. I've got my pink 10,000 Racerstar motors. These are not the newer ones that have the 4 holes in the top. These will be a little bit lighter, I believe, than the ones that do have the 4 holes, and that's something to consider when we're building micros like this. This will be one of the smaller builds. Also, we have, see if I can make this focus, give credit where credit's due, made in Canada. And it looks good. Good, clean, sharp milling on all this. Pretty happy with that. The stickers won't make it through to the build, but anywho. And also in the kit, you've got 1 prop cutter here. I believe you just use your fingernail clippers along here and use some sort of metal fittings to keep your fingernail clippers in place. A second prop cutter, and this is 3D printed as well, and we just work that off. We set our quad blade down in there, put it back on, and clip, clip, clip all around the edges. So that's an ingenious design there. Good job. I appreciate new designs. We hadn't seen anything like this. This is I wish all of our micros that needed prop cutting would come with something like this. It would make life a lot simpler. I know the first few times I tried to cut props down, it didn't go very well. I've since gotten a couple of prop cutters, so I'm a little bit more efficient at that. Also, the struts are printed out of TPU, and to show you that, so those will absorb those impacts that we have, but it could hit the props. We'll see how that goes. These pieces where our ESC and our flight controller go are also 3D printed, and you can see there on the edge they build up a little bit between each piece. This is also printed in TPU. It's part of the stack, I believe. And then we've got our center pod, and this is how we've made this so small. This is supposed to be 59 millimeters motor post to motor post, and this is how we do that. All our wires have to go, well, our camera wire has to go down through there to our flight controller. And then we have 2 different styles of camera mount. We have this one here, when we just clip our camera down in there, and then we have a little space here to lay our receiver nice and safe. And then we have this kind here, which this will fit the shell that you can make yourself. I happen to have one. Let me grab that. This is one of those shells I was talking about. I think I need to do 1 more coat. It's a little bit thin around here in the front, but I'll do that while we're building. But you recognize this from the tiny hoop. You can place your camera right down there. I need to poke a hole in the bottom for my connector and wire, but that would sit. It either goes this way or this way. I'm pretty sure it goes the other way, but we'll figure that out as we get there. Well, probably not. It probably does go this way. So I'll need to bore out some holes, I think. Possibly. We'll see. I might not use this, though, too, because I do like to keep the profile down. If we use this, I think the profile will come back up. But those are the major pieces here. I also want to bring your attention, I am using the Bold Clash F01. You can see here on the front, if it'll focus, it says VM275. Get this online as well, and it comes with 2 extra antennas. Of course, I'm going to keep those around. I do like these because this longer antenna is quite flexible. And lastly, we have a printed schematic here of all the pieces and how it's laid out. I hope to use this a lot because we do have a number of different pieces, and this is a fairly untraditional build. Most of our stack is actually going to be below the frame, and then we separate the frame from the camera using this guy here, as you can see in the picture. But it's nice that we get this, otherwise you'd be searching online for pictures, and I found a few that I think will be useful. But I always enjoy that Tomo sends these along, and it tells us a little bit about how to secure this down as well. And we've got what I believe is just about all the hardware, so I don't know if we're going to need a kit like this in order to install this one or not, but I've got it handy just in case. Let me get reorganized and we'll get started. We're fairly zoomed in here, but we're ready to go. I went ahead and mounted the motors because, well, you can mount motors, and you see we've got holes here. I went ahead and threaded them through there. I don't think we necessarily have to do that. I think we could get them through these holes in here if we wanted to, but I went ahead and threaded them through there. If you look online, some of the original pictures, I don't think the frame originally had these holes. So your pictures, if you look online, it may vary between having these holes and not having these holes. I think they may have come later after he made some frame refinements. And we will have to rotate everything 45 degrees in our flight controller software, and you'll get to see that here after a bit. And with the ESC mounted upside down, this side of the motors are going to line up just fine. It's just motors over here that we'll have to reverse. And we're going to go ahead and tin up some of the locations we're going to use on the the ESC and on the flight controller. I'm going to be using Spectrum, so that means I have to tin up this pad right here to get my 3.3 volts, and then we'll do our signal on all four corners because we need those from the ESCs. And we can also tin up our battery pads because we'll use the plus and the minus off of the ESC right there to power the flight controller. Then over here on this side, this is our ground and this is our signal. If you're using a different receiver, you may also use the 5 volt from right here. Spectrum takes 3.3 volts, so we have to get that from over here. They've organized this board in that particular way. There is a manual online you can find, and I'm actually looking at that up here on my monitor just to make sure I do everything right. It's always good to have our instructions out no matter how many times you've done this. I think I've done one other with the femto. This might only be our second. So let's go ahead and get that going. I've zoomed in so you can see this a little bit. Tinning these pads, pretty straightforward, get in and get out. It's pretty tough. You want to have a pretty fine tip. You want to have it clean and pointed. Bring some heat, put that on there. Oh, missed. Oh, sometimes you can just rotate that blob over. I always add a little bit if I ever do that. Okay, and then our 3.3 volt here. Oh, well, geez, I got to clean that off, don't I? That's the challenge with these, is getting the pad hot and getting the solder on there. And our ground comes from trying not to cover this up and also trying not to break anything. I'm going to turn this a bit so I can get a better advantage point on it. Using blue tack, of course, to keep this down. I'm going to add a bit over here. I don't like that one. And then we'll do our battery pad as well. Alright, now we're ready to go over here. I'm going to rotate this one. Careful not to burn myself. Lots of smoke. Maybe you can... I need a little fan or something. A little 5 volt fan to blow this out of the way so you guys don't have to look at the smoke. It'll just clear a little quicker. Alright, there's our tinning. I don't think I covered the fact that I did double up the sticky tape that was here so I could bring this up to just above flush. This piece here will give us some gap above our flight controller. I think that will work just fine. If I have to reverse course on that, I will surely note it. So of course this is our tail. This is our tail, but it doesn't necessarily fit. We have to rotate everything, right? So we'll be going in here like this. And then we'll use some nylon standoffs under there. So this is how our stack looks right now as we've got everything assembled. You can see on this lower portion here, we've got the gap up top below. There's that little tiny string of TPU there, and then it's the spacer above it. In this case, the spacer is below and the TPU is on top. If the TPU is down, it would be kind of difficult to get all the way down because of these little bits right here. I think at this point, I need to get this connected. And I need to connect our wires to our flight controller here, otherwise that might be kind of difficult. And we're just going to go straight through. My typical method is I figure out which motor I've wired to which ESC and then match the signal wire up. In this case, because we're rotating and we've mounted upside down, we should be able to just go straight into. And we also need to hook up our ground and our positive. So I'm going to get those all prepped up. We'll come back and do that. I've got my wires shortened, and all I did to shorten the wires from the ESC to the flight controller was just kind of do a dry fitting with my fingers. It's going to be really tough to see. We're zoomed in as well as I could, but really all I did was just take my fingers, pinch the wire where I thought I should cut it, give myself a little bit of slack so if I need to pull this connector out I can. We're not going to be able to lift the flight controller up off this stack very well, but we're just on sticky tape, so maybe that will help us if we have a repair. And of course the shortest wires that we have down here, I think you call it blue and green, they go to the signal wires, signal pads down here. Let me get my pointer again. So we've got that one here, and we've got another one right over here we'll connect to. Also, I didn't tin a pad that I'm going to need to do the soldering for the camera. Our camera is going to run off 5 volts. You can, again, look at the manual, but ground is up here. This is 5 volts here. You could also get your 5 volt from there, but because I'm going to be using a receiver over here for Spectrum, I'm going to leave that area just Spectrum. You can also hook up an S-Bus receiver over here. This area up here is for a PPM receiver. So I'm going to go ahead and do that. I may have to actually kind of dry fit everything and get a length on my receiver so I know, because I think I'm going to have to get that soldered on before I can proceed on to connecting this tiny little stack up to the bottom of our frame, and then we'll do the motors. I'm kind of zoomed in here, and the reason why I wanted to zoom in and show you this is these tiny little wires have tiny little threads, and you want to be very careful before you do your tinning that you make sure all those threads are together. And what I do is I really can't feel what I'm doing, but I just pinch and I rotate and try to get those threads all around each other, and then I tin them up. And the one reason why you do that is you get one little tiny thread that's not connecting to the right pad, it's connecting somewhere else. You can end up with weird problems, or even worse, a short and a dead board. So be careful, take your time, and I'm going to tin these pads, and then we'll come back and we'll actually connect them up. I'll try to show you that. I've got my little tweezers out here. Hopefully I can get a little bit of a camera view into that spot where these are going to go. Again, one thing I didn't cover as I go back and forth, I did this before I started filming, but plug your board into your USB connection and make sure you can access it via CleanFlight. This one came with CleanFlight, so I flashed it over to Betaflight 3.1.6. So if you want to change the firmware on there, make sure you can do that before you get it all mounted up. One of the few sad things about building is to build something and find out you got a dead board. There's really not much you can do to find out whether you got a dead ESC other than to plug it in and try it out. Hopefully, though, I haven't had too many problems with these boards or these ESCs. I've only had one ESC that's been dead. I had a short on a 4-inch build that I didn't video, which actually hasn't been on the channel at all, where that ESC had a short in it, and I found that out after I got it connected. Then I had to go to my 5th one, which I did have. So let's go ahead. I'm going to go ahead and do our positive and negative here first. I'm going to start with the negative, and I've actually got these a little longer than they need to be. And we're just going to do this. You can probably see better than I can. I've got my blue tack under there again. Jeez, it keeps moving around. Did I get that very well? I think it's down there. Okay. So let's start with our closest one here. This is for motor 1. And I have to kind of curl it around here a little bit, so I'm going to bend this down. Bring my iron around from this side. You probably can't see this one because it's right behind that standoff. This is motor 2. You might be able to see this one a little bit. I might have cut this one just a touch short. And you'll note that I didn't go between these. And I didn't do that because sometimes when you're doing these builds where you have to rotate things 90 degrees, that you might want to change the orientation of these connector, or you might want to change the orientation of the wires to where they come off at a bit of an angle one way or another. So I didn't want anything between there that I might end up getting my iron on and causing extra work. I cannot see this one at all. Nope, didn't get it. There, I got it. Boy. There we go. Finally, I want to keep these away from where I'm going to be putting my receiver. So I'm going to go right up here around the middle. Alright, we're in good shape. So then we need to put this on here. Slide that on. See, this is where I think I'm going to have to do my receiver now before I put this stacked on, because there's no way I'm going to be able to connect anything down here. And I think flying this one in stable mode is going to be a bit of a challenge as well. You're going to try to accelerate, you're going to try to calibrate the accelerometer, but as you can see, that board's not going to sit flat. So you make sure you calibrate when you do get it flat. It should sit flat on whatever surface you have on these screw heads, but relying on the pre-calibration is not going to work. So I'm going to do a bit of a dry fit here to see if I can find out what kind of length I need for my receiver. Okay, so obviously I can't read. So if I would have looked at this even more closely than I thought I already had, we would see that I had done this wrong. And you can see that I've now switched my flight controller up top. And the only reason it occurred to me to look more was I thought, man, it is really going to be a tough build getting those wires through all these bits. And it still will be. It'll be a challenge to get that 5 volt and our receiver wire, because our receiver is supposed to sit down here, through this hole and down here. But it was going to be especially difficult. And I started looking at it a little closely, and I can see that I had originally put it together wrong. So your flight controller actually goes right down to the frame like it would traditionally, and our ESC is just below it. So it looks, the stacks looks a little bit like that. And I had left myself enough slack to where I didn't have to really disconnect anything. I just picked 2 wires on one side, take those off, so I had enough space to put the board down in there and then put it back through. So now we're all reconnected up, and I think what I need to do next is to put the ESCs and the motors together. And I'm just going to line these up. So normally, you know, this would be the nose, and in our case, this is going to be the nose. It's going to fly a little bit like this. A lot like it did on the Swirly, I believe. It was actually the other Tomo frame that we did, the Swift, the big brother to this one that has the board orientated just slightly different, but will still fly forward this way. So we won't be looking at one motor in the front. Sorry, that was a bit confusing. So I'm going to step away because this is going to be fussy, and I'll take the motor wires and we'll just, let's see, this is motor 1, and we'll take these wires and I'll probably tuck them up in here a bit. I'll maybe use a rubber band or something to keep things nice and clean underneath here, and solder these to the ESC, and then I'll probably route this one through our little gap out over here to 2, and then over here is where we need to swap around our motor wires to where they line up. I think I explained that just backwards. So this is motor 1, it'll go right here, motor 2 right there, motor 3 right over here, and motor 4 will go right there. I'm going to step aside for a minute, and I don't know if I'm going to film that or not, because if I can get a good advantage to where I can actually film this and show this to you a little bit, I will, but if not, we'll proceed on from after that. I've got the ESCs all wired up, and you'll see that I didn't use the top pads as I tinned. I went ahead and I tinned the bottom, and I used those because the access to the bottom is far greater than it is to the top, because we've got these arms in our way, and I probably should have known that. Some of you may be getting a laugh at me, and that's okay. So we've got a good portion of it wired up, and now we're ready. We can go ahead and put this piece back on, but we're doing a dry fit here, because as you know, I don't have my receiver or my camera wired up yet. And I'm thinking I may end up having to use some sort of connector. So we're just kind of wiggling this piece around down here. Then this piece goes like this. Looks like we're going to have to do something on our own back here, because I don't think the kit came with anything to do anything for this, making sure that goes down flat. Maybe it's of no concern. Maybe it's just a couple of nuts. I'm just not sure yet. And then we would normally have this, which we would secure down there. This frame, you see how everything's starting to line up there. It goes on top. And then we would have one of these pieces. I think initially I'm just going to go with this. So my receiver is going to have to go. It should reach just fine. I'll just clip the ends and solder those on. But how am I going to do that with this assembly? That's the big question. Well, let's start working through this a little bit. Maybe I'm getting ahead of myself and I'm trying to build from the bottom up, but I need to be building from the top down maybe. Alright, let's start with a frame. Camera plate. And this guy, we need to line these all up so they all go through here. You can see we've got holes. They all do line up. So I think let's start with this one out on the nose. I believe we use these black ones. Why didn't you get that all the way down? Already starting to strip it. That's no good. Time for a different screwdriver. Let's see how this one does. I've already done too much damage. Wow. So, those are, you can see I've done some damage to that already. Dang it. But they're in there. Now we need to go here and here. Right? Will that line up? Or did I already do myself in? Let me try to get some extra light on that. I thought that front one was going to be out of the way. Oh, and I've got it on there upside down too. Jeez Louise. So off she comes. Okay, so according to the drawing, this little cutout here, that's where we're routing our wires actually through, I think. There isn't a clean shot of where the wires actually go, if they go down through the hole or if they go through the back. I need to take another look at this. Let me just do it this way. Yeah, see, that hole is covered up. Doesn't even go through there on its own. You gotta kind of bore that out a bit. That goes through this hole, which that doesn't hold on there either. Maybe I'm using the wrong screws. Well, I sure don't think so though. Okay, I got that started. I don't want to get it tight before I go on to the next one. Have some guesswork to do here. Okay, I can see it's coming through there a little bit. Okay, so there's the top assembly. That's not great, is it? Oh, especially not over here. I need to back that out and get that flat. That won't work, not like that. I think I got it now. Wood seems to be kind of leaning forward. Can you see that? Okay, let's proceed. Let's act like we know what we're doing, right? So this piece then gets secured to the bottom of this. And that's why the front hole is there. This has got to be one of the most challenging builds. We've got a lot of little tiny pieces here that we're having to sort out how this thing goes together. Even with the exploded view diagram, at least it's a little bit foreign to me. Until I'm kind of bearing down. See, look at that still. You got a gap over here. It's probably as good as it's going to get. Okay, so that would go like this. But we still have to put this piece on. I've got to get everything through that stack. So I need to chop some wires. I think what I'm going to do is, if I have to, I'm going to leave the wires a little bit longer, because this is all got to go down through here. And then to the board. And we really can't put the camera down into the mount until we've done all this. But there didn't seem to be any easy way to go about doing this that I see. Okay, I am going to have to figure this out. We'll come back after I've sorted this out, probably 2 hours later, and I'll show you what I've got. Here's my top assembly. And you can see I typically with these Spectrum satellites you get some of those plastic covered, or they're much more rigid, so I took some wires out of the bend that were going to be much more flexible. That way I could give myself a little length down here, and if I needed to, it would just go up into that pod. I figured flexible wires are going to work better. And then I've also got my camera. This is pretty firm, but just kind of wiggle it back and forth as you're sliding it down, and it will go in there. It does hold it very well, and we've got a little bit of up tilt with that as well. So nice things there. I'm going to try to film this, and this is going to be a challenge. This whole build has been a challenge, hasn't it? But these are the ones I really like. The 4 and 5 inchers, it feels like you can just put those things together so quick. I enjoy building those as well, but I think there's something about the accomplishment of these that I enjoy a little bit more. I think this is going to make it really difficult to film. I'd like to have the wires lay down this way. So I'd like to have this back here. Let me turn these. Now where'd my solid pads go? Oh, I'm going right up here. So the outside is negative, inside is positive. Now I need to grab it with the other hand because I'm going to be using my soldering iron over here. This is all going to be a challenge. I'm trying to film it. We'll see if this ever makes the cut. See if there's anything that I can use out of this, huh? If I can lay that right down in there, that would be what I would prefer. Looks like I got that one. Nope, didn't get that one. Shoot. Gonna have to get my hands in the way, I think. That doesn't look good. I can barely see that. There. I'm much more happy with that. Now that we've tied the top to the bottom, try to get the receiver so my 3 volt is going to come from back over there. I think I'm going to do that one last. And I'm going to move that around this wire to the camera. So back over here, got ground at our lower pad, and then the signal up here at the top. So let's do signal first. because I still have to put this piece on yet. So I'm gonna angle this. Whoa, my bottom's moving here. Okay. Fetch our ground out of here. I'm gonna bring this kind of around. Little pull there. Now I should be able to put this. No, because it's going to go on right across there. I better finish my wiring here. I'll flop this all over. I'm going to go right down to that pad. Looks like that standoff is going to be in our way. Hopefully you can see something. Or I'll have to cut this all out and it'll all be movie magic, right? That wire's awful close. So now, this should go this way. So I need to put this on. Sorry, you can't really see this. It's not a great view. It's probably why we don't find a whole lot of build videos for micros, is the view is so tough to manage. Now my flight controller is in the way of this one going down. How am I going to get that out of the way? There we go. No, I sure hope that we don't get a short from this carbon. It should be isolated. So then this would all go down here like this. This is sticking to my fingers. Alright, so now all we have to do is put the nylon nuts on. And I bet that is going to be a bit of a chore too, just like everything else. Let's see where they all go. 1, 2, 3, 4. And it's nice that we have some extra bits here. We still have the struts to do yet. But I think we're going to we have at least one long nylon that's extra, because we will need to chop those off after we get our nuts on. Got an extra nut there. I think the silver ones go on top. Those are hexes. Do I have 4 of those? I only see 3. Did I miss one? Did I leave one in the bag? So either I've scooted one off my desk here, or I'm missing one. Because I think those go into the top through the frame. I think that's where these silver ones go. I suspect I rolled it around on the desk somewhere. I'll see if I can't find that here later. Let's go ahead and try to get these nuts on. I'm going to show you a bit of this. I guess the easiest part would have been to do this before this back one. This back one doesn't have anything it's securing, so there's no real support structure to it. At least nearly as I can tell. I don't claim to be an expert. This is one of Tomo's great micro designs, and I am just trying to figure it out. Now, of course, I still have my battery lead to do as well, and check for shorts. There's one. That wasn't too bad. But these are the ones that are going to be a challenge. So I think they all need to get started. Oh, that whole thing was almost out of frame. Sorry. This is what I'm going to do. Try to lay it here on its side. Maybe. Can you see that too? Ah. The needle nose might have to make an appearance. Whoa. That one left. Well, I have spares of those. So we'll have to dig into my kit probably. But, oh yeah, I forgot he left a spare for us. Let's try again. Using the needle nose, I can get a better grip, more pressure. Okay, that one's going on pretty good. Several things in this build that we probably didn't videotape, but I apologize. I do all that I can to try to make it as complete a build as I can, but if there's nothing to see, and I'll have to review all this footage, there's just no point in you listening to me all the time. Ooh, this one doesn't like its spot. Let's go this way. There, now we can start to cinch them down. And as you can see there, because this doesn't go off, I'll just snip that off at the top. It doesn't support anything on the top half. It's all the 3D printed bit in there in the middle that was pretty firm getting those screws through. I'm not going to bear down on these too much. That TPU will squish quite a bit. But all that TPU also acts for vibration dampening to some degree. That stack's kind of tall though, isn't it? It feels a little too tall to me, but I bet you this one won't suffer from the issue where the back end drops because of the guard, because the guard is so thin and most of the props aren't really protected so much as this is just kind of a bumper. But it does look like this piece could be brought down a little bit. Do I have that even level? I think I've got this one tighter than this one. I'll sort that out. I'm going to put my connector on here. I'll probably put some Duralock here on the bottom. And I didn't pay any attention to how I wired the ESC wires. Trying to keep that straight is going to be a mess. So I'm just going to use BL Heli to reverse direction where it's needed. And we'll go through that here in a minute. I'm a little bit confused what these little nubs are for. They don't seem to have a purpose. Okay, so I'm going to try to work on getting this thing flat. Okay, let's go through these last bits. I noticed that there are a couple of slats cut on each side here. Let me get my pointer again. Right here where I've got my antenna tucked. So I just put them in there. I don't know if that's the intended use or not. But I'll add a dab of hot glue up here to the top. And I've actually got that warming up now. And we can see it still looks like it's leaning. But when I sit it flat on the table, it is flat. I've got my eye line down there and I checked that. I still don't have my JST on there, but I'll do that in a minute. I checked for shorts, and that all checked out good. These TPU printed struts here, I'm calling them struts because I don't know of a better name. I did apparently misplace one of the silver ones, so keep track of your parts. Do better than I did. Just don't crank on them too hard. You know those are printed, so you're not going to make a real hard connection. What I did was I just put my fingers here, and I could feel it get intense. Well, I wasn't using this, but as I was screwing it down, I could feel it pull tight. I give it just, another quarter, maybe almost a half a turn. Called it good there. And it did the same on the bottom. So I'm going to get my JST put on here, and then we'll connect it up to BL Heli, and we'll see which side, which motors need to be rotated. Maybe all of them need to be reversed. We did end up with a few extra pieces. We got some extra screws. We got an extra camera mount that would go with that canopy. I opted not to go with the canopy. Just because I think that's going to bring the profile up more. I'm kind of sensitive to a higher profile. Myself, I think that middle piece, and I could do this myself with just a knife, is just take a couple mil out of that. I think we can bring that down, but that's going to cause problems with our struts. So, I mean, this is very much just personal preference. I like a lower profile. I had a designer help me design a 3-inch frame that was a smashed, or not a stretch, but a smashed X. and that brought the profile down because our gaps sometimes not only they narrow from motor to motor, but they're sometimes narrow this way too. I'll also add some heat shrink here to the bottom. I'll put a piece that's big enough to go around here to give this joint a little bit more strength and rigidity, because we'll end up landing on this a lot, so I don't want that getting damaged. So hot glue here, heat shrink there. Props. So he included this prop cutter. I have a bunch of 1935 Racerstar props, which are just about this exact size, but as you can see there, we can get a couple extra mil, which may mean the difference between a great flight and just a good flight. So I am going to use the handy dandy cutter that he sent us. I've got the bag just here off screen. I've got a whole baggie of them here. I'm going to get the longer ones out. Should be pretty straightforward if I can get this down all the way. And then we'll just clip them off. So these are fingernail clippers. You could probably be better off with toenail clippers, but this will work. So I can't get it all the way down there because of the center piece. So I just chop, and then I chop again, and I do that all the way around. There we go. Now we got ourselves the perfect size Tiny Swift props. Pop that out, pop that on, do that for the rest of your props, and you're good to go. But the next step, we're going to go ahead and do the motor reversing. We're all set up here, and as you can see, I had to take the motor screws out of motor 1 here in order to be able to plug in our USB, and even my fancy dancy little right angle cable here. That didn't fit either. I'd shaved this end off so I could work on some of those others, but in this case we can't do that. It just won't fit. So maybe you have a fancier cable than I do and it will work, but this is what we're going to. So we're just going to connect to Betaflight here, and we're going to go down to the motors tab. We're going to scroll down here, we're going to slide this slider, and we're recognizing that we don't have any props on, as we don't here. Plug in our battery so we can spin these motors up. And I just put my finger on here, and I use the top because I can feel that a little better than the smooth side. So motor 1, that felt good. Let's go to motor 2. Motor 2, that's even good. Let's go to motor 3. Sometimes you have to slow it down a little bit to feel it. Motor 3 feels like it's spinning in the right direction too. Maybe we got lucky. Yeah, motor 4. I think we got lucky. Let's go ahead. Let's move that slider over. Let's disconnect. Let's presume that motor 4 needs to be reversed. So let's jump into the BL Heli app. Now you do have to have Chrome. So you'll need to go to google.com/Chrome and download and install that browser. And after you do that, you can open up a new tab, and then in the top left area you'll see a text label called Apps. You click that. That will take you into the web store, and search for BL Heli, and then click Install. That will bring you to the point where you can run the BL Heli app, which you see on your screen now. So with the BL Heli app, we can now click Connect with just our USB cable. I don't have the battery currently plugged in. And you'll get this screen. Now we go ahead and we plug in our battery, and we click Read Setup. Now we've got all our ESCs listed, and we just scroll down here to where we see ESC4. Remember, we're operating under the premise that ESC4 or motor 4 is rotating the wrong way. We click this drop down arrow, we click Reverse, we click Right Setup, and then it wrote the setup. Now motor 4 will be rotating the opposite direction, which is our correct direction. That's all there is to it. Main thing is you've just got to have the BL Heli app, and you've got to have Chrome. Here we are in Betaflight, and as you can see, this is the Pico target. And let's go ahead and connect. As you can see, we're running the Betaflight 3.1.0. And we've got the SP Evo, but I'm running the Pico target on this because I noticed whenever I flashed, let me see if I can find that again, Pico board, whenever I flashed the SP Racing target, it would brick the board, and then I have to boot pin and then go right in, or I'd have to use DFU mode. But here we got the quad, we got it all plugged in. Now remember, I've got the board misaligned in here, so you don't want to rotate yours the same way as you're going to see in here. You'll actually want to do it the opposite of mine. So normally you'd be in here and you'd calibrate your accelerometer if you use level flight. I fly acro pretty much exclusively now, unless I'm flying indoors with a brushed micro. And our ports, I use UART3 for serial RX, so I can get my satellite spectrum up and running. Configuration, I use motor stop. A lot of people talk about using air mode and having motor stop disabled. I use motor stop and I set an air mode. That way I can have acro without the motor spinning when I'm armed, and then I can turn on air mode, and I'll show you that when we get to the modes tab, and then the motors spin. So I can still do, or I can try to do acrobatics. We'll scroll down here a bit if I can. And here's what you don't want to do. I have minus 45. You don't want to do that. You actually want to have 45. And you can see my receiver settings. I haven't messed with the battery voltage at all. You might choose to do that. I have not. You can see we're running 8 kilohertz and 2 kilohertz. That's the default. I went ahead and disabled everything in this section because there's nothing there that I use. Now on my final PIDs here, this is what I have. And pretty much all I changed was a little bit of I and a little bit of P. Actually, I changed quite a bit of yaw P because that gives you more authority. And then I use really high rates. If you don't like really high rates, don't use them. Plain and simple. I use higher rates than I think many people do because I've had my rates seen as criminal, as one person in RC groups posted it. And when they posted that, I thought, do you not know how to change your RC rates? But anyway, so I like really high rates. I like to have small stick inputs, and that's how I like to fly. But you can change these. It's not a big deal. Nothing really down here to see. Jump into our receivers tab. I don't have it connected. There's really nothing there for us either. Now we'll go down to our modes, and you can see that I've essentially got 3 modes. I've got an arm, switch, and then I've got our 3 modes. I've got air mode, I've got angle mode, so when I'm flying line of sight I can use angle mode, or if I'm having a really bad day of flying I'll fly angle mode too. And then when this switch isn't active, aux 2, then I'm just in straight rate mode. So if I'm in aux 2 in the middle position, I'm rate mode with air mode on. And you can set your modes up any way you'd like. Down here at the motors tab, this is where you calibrate, and I'll show the calibration and reverse direction for motors in the build video. And we drop down to the CLI. See what we got going on there. We've already seen the version, but I'll go ahead and do it again. Oh, and one thing. I saw this in Albert's video. He did some special filtering on his. Oh, it's going to give me fits. I got to disconnect and reconnect again. I'll be right back. So Albert went into the filter settings and changed some of his stuff. I have never tinkered with these settings, so if you have questions for me about filter settings, I don't really have any answers. I'm sorry. I don't know why it is. The way I build the props that I use, the motors, the batteries, the way I mount, I don't know. I've never really had a problem with vibrations. The only machine I've really had a problem with vibrations was pre-built. It was that Eachine Chaser 88, and I found out that it was just a bad board. It seems like they used a bad board on all those models because a lot of people had the same problems. Once I swapped out the board, that machine flew fine. So these are all stock. Tinker with them if you like, but I didn't use anything here.